One of the most famous stars in the whole night sky has been keeping a secret for about 100 years.
And this week, a telescope in the Chilean desert finally caught it red-handed. Betelgeuse, it turns out, is not alone.
Also ahead, a black hole caught wandering the lonely outskirts of a galaxy, treading a star tens of thousands of light years from where any black hole has a right to be.
NASA's next great observatory gets its tank filled and a date on the calendar.
And the little spacecraft sent to rescue an aging telescope suddenly needs rescuing itself. Good day, and welcome to Astronomy Daily, your daily dose of space and astronomy news. I'm Avery.
And I'm Anna. It's Wednesday, the 29th of July. 4 stories and a look at the sky from both hemispheres. Let's get into it. If you've ever looked up at Orion, and from Sydney or Seattle, just about everyone has, you've seen tonight's star, Betelgeuse, that deep orange point marking the hunter's shoulder. It's a red supergiant, roughly 650 light years away, and it is enormous. Drop it where our sun sits, and it would swallow the orbit of Jupiter.
And it's famous for misbehaving. It flickers.
It does. Betelgeuse brightens and dims on a whole set of overlapping cycles, and people have been writing that down for more than 1,000 years. But there's one rhythm in particular, a slow beat about 6 years long, that astronomers have never been able to fully explain. And for almost a century, one idea kept coming back. What if Betelgeuse has a companion, a second star, orbiting close, tugging on it?
The famous Betel Buddy.
That's the affectionate nickname, yes. The trouble is, nobody had ever seen it. And you can see why. Imagine trying to spot a candle sitting right next to a lighthouse. Betelgeuse is so blindingly bright and so physically huge that any little companion tucked in beside it just drowns in the glare. For 100 years, it stayed a hypothesis.
So what changed?
A team led by Miguel Montargis at the Paris Observatory in Chile, the VLT, and an instrument called Sphere that's built for exactly this job, blocking out a bright star to hunt for faint things right beside it. And crucially, they picked their moment. They observed in December 2024, at the point in the orbit when the companion was predicted to swing out as far from Betelgeuse as it ever gets from seen from Earth. Best possible chance to split the two apart. And there it was, a faint little source right where a companion should be. Their paper landed yesterday, the 28th of July, in the journal Astronomy and Astrophysics, and Montargis called it the end of a century-long quest. After 100 years of arguing about it, we have a direct image of what is very likely Betelgeuse be.
That gives me chills, honestly. A star that people have watched since antiquity, and we're still learning brand new things about it.
And here's the lovely twist. The reason they could see it at all is that it surprised them. The companion was predicted to be roughly the mass of our sun, but the data say it's bigger than that, something like 2 to 3 times the sun's mass. Montargis put it beautifully. Because it's more massive than we expected, it's brighter than we expected. And that's the only reason it peeked out of the glare. If it had been as small as the textbook said, they might have missed it entirely.
So the companion did us a favor by being chunkier than advertised. What is it, though? Another supergiant?
No, nothing like Betelgeuse. Think of it as a young, hot, fairly ordinary star, but locked in a very awkward orbit. It appears to circle so close that it's essentially skimming through the outer, puffed-up layers of the supergiant, and that has consequences. That orbit is almost certainly what paces that mysterious 6-year brightness cycle, but it's also most likely a death sentence for the companion.
Ooh, go on.
Plowing through a supergiant's outer atmosphere means constant drag. Every orbit, the little star loses a bit of energy, and models suggest it's slowly spiraling inward. On astronomical timescales, Betelgeuse is very likely to swallow its own companion. Not tomorrow. We're talking thousands of years. But the relationship is, let's say, not built to last.
The lighthouse eats the candle.
Eventually, yes. And this matters for the big question everyone actually wants answered about Betelgeuse. When is it going to explode? Because it will. It's an old, massive star near the end of its life, and one day it will go supernova and briefly outshine everything in the night sky. Now, before anyone emails us, that's expected on a timescale of up to 100,000 years. So don't cancel your weekend. But whether a star has a close binary companion changes the whole picture. How it sheds mass, the shape of the gas around it, even the choreography of the explosion when it finally comes. Knowing Betelgeuse is a pair rewrites part of that story.
And this was direct imaging, an actual picture, not just an inference from wobbles in the light.
That's what makes it land. There had been circumstantial hints for years, but this is a direct detection. Light caught from the companion itself in the right place at the right time. It's the difference between the data suggest a second star and here it is.
So if you want to go and look at the star at the center of all this, Betelgeuse itself, where are we, both hemispheres?
Right now, Orion is a pre-dawn act. It's climbing back into the morning sky after being lost in the sun's glare. For our southern hemisphere listeners, Orion rides high in the northern part of the early morning sky, and it's upside down compared to the northern view. Look for Betelgeuse as the bright orange star. From North America and mid-northern latitudes, it's lower in the east-southeast before dawn, climbing higher each week as we head towards the northern winter. We'll come back to it properly in the Skywatch. But next time you find it, just remember it's not one star. It never was.
Now, from a star that's hiding a companion to a black hole that was hiding full stop. Anna, picture a supermassive black hole. Where is it?
Dead center of a galaxy. That's the rule. The big ones sit in the core.
That's the rule. And this week, NASA's Swift Observatory helped break it. Astronomers announced a tidal disruption event. That's the technical name for a black hole tearing a star apart and eating it. And the flare it produced was blazing, briefly outshining its entire host galaxy in ultraviolet. Like 10 billion suns switched on at once. But here's the thing. It didn't happen in the middle of the galaxy. It went off about 30,000 light years out from the core.
30,000. That's not a rounding error. That's further from the center than the sun is from the middle of the Milky Way. That black hole is out in the suburbs.
Way out in the suburbs. The event's called TDE 2025 ABCR in a galaxy about 750 million light years away. And the teams, one led out of NASA and the University of Maryland, another from UNC Chapel Hill, published it on the 27th of July in the Astrophysical Journal Letters. It's the most off-center tidal disruption ever seen, and what it reveals is a wandering black hole, around 1 million times the mass of the sun, just roaming through its galaxy, nowhere near the core.
How does a black hole end up out there? They don't exactly stroll.
Best guess is a galaxy merger. When two galaxies collide and their central black holes get thrown together, one can get kicked out of the middle and left drifting. Theorists have predicted these wanderers for years. The problem is they're invisible. A black hole sitting quietly in the dark emits no light. You only ever catch one if it does something dramatic.
Like grabbing a passing star and lighting up.
Exactly. The star is the flashbulb. It wanders too close, gets shredded, and for a few weeks the wreckage glows and gives the whole thing away. That's the only reason we know this black hole is there at all.
And there's a lovely modern wrinkle to how they found it, isn't there? This wasn't a human squinting at plates.
Not a chance. The sky is too big for that now. The initial flare was picked up back in November 2025 by a survey at Palomar in California that scans the whole northern sky every couple of nights. It throws up something like 500,000 flashes every single night. So the team trained an AI to sift that fire hose and flag the ones that look like a tidal disruption. And it caught this one precisely because it was in a weird place, off in the outskirts where nobody would have thought to look. Swift followed up to nail down the details.
And that's a taste of what's coming, right? Once the big new survey telescopes are running.
That's the real headline under the headline. With observatories like the Vera Rubin Observatory and UNC's Argus Array coming online, we go from finding a handful of these a year to potentially hundreds or thousands. And suddenly, all those invisible wandering black holes become findable. We're about to start taking a census of the galaxy's hidden monsters. And keep SWIP in mind, by the way.
Because it's going to come back to bite us later in the show.
It is. Hold that thought.
Speaking of survey telescopes about to change the game, let's talk about one that's now, genuinely, nearly on the launch pad. NASA's Nancy Grace Roman Space Telescope, because as of this week, it is fueled and counting down.
Fueled. That's a real milestone. That's not a slide in a presentation, that's propellant in the tank.
Precisely. On the 25th of July, teams at Kennedy loaded around 290 gallons of hydrazine into the observatory. That's the fuel it'll use to hold its position and point with real precision once it's out there. And NASA is holding its big mission preview briefing today, exactly 1 month out from launch. The date to circle is the 30th of August, and remarkably, that's about 8 months ahead of the original schedule.
A NASA flagship running early and, as I understand it, on budget. Let the record show it can be done.
It can. And here's why Roman is worth the excitement. Think of it as a telescope with Hubble quality sharpness, but a jaw-droppingly wide field of view. Something like 100 times the patch of sky Hubble sees in a single shot. NASA's estimate is that in its first 5 years, it could image more than 50 times as much sky as Hubble has in 30. It's built to survey fast and wide.
And what's it actually hunting?
2 headline jobs. 1, dark energy, the mystery pushing the universe apart faster and faster. Roman will map how cosmic structure has grown over billions of years to pin down what dark energy is actually doing. And 2, this is the one I love. It's an exoplanet machine. Using a trick called microlensing, Roman is expected to find more than 100,000 new planets and to catch hundreds of others in the very act of forming around young stars.
100,000. We do a story most weeks about one interesting new planet, and Roman's going to hand us 100,000.
It really might reset the whole field. And this is genuinely for everyone listening, wherever you are. It's a space telescope. So there's no hemisphere that misses out. The whole planet shares this one. 1 month to go.
Fingers crossed for the 30th of August. Right, I told you Swift would come back around. In Story 2, Swift was the hero, the observatory that helped us catch that wandering black hole. Well, here's the sting in the tail. Swift itself is in trouble, and the spacecraft sent to save it is now in trouble too.
Set it up. Why does Swift need saving in the first place?
Because Swift is falling. It's a fantastic gamma-ray and X-ray observatory that's been working since 2004, but it has no engine of its own, no way to boost its own orbit. And its orbit has been decaying faster than expected, partly because heightened solar activity puffs up the upper atmosphere and increases the drag. Left alone, Swift is looking at an uncontrolled re-entry by around the end of this year.
So it burns up, unless someone goes up and gives it a push.
Which is exactly the plan. A company called Catalyst Space Technologies built a robotic servicing spacecraft named Link, and NASA hired them for what its own mission director called a fast, high-risk, high-reward rescue. Link launched on the 3rd of July, and the goal is genuinely a first, to fly up, grab hold of Swift, a satellite that was never designed to be docked with or serviced, and physically boost it into a higher, safer orbit. Nobody has ever commercially docked with a government spacecraft that wasn't built for it.
That's ambitious. So what's gone wrong?
Over the weekend, Link ran into an attitude control problem and started spinning, with its communications dropping in and out. According to NASA's update, and I want to be precise here because this is developing, the preliminary finding is that 2 of Link's 3 reaction wheels are no longer working, and there's some loss of function in its cold gas thruster system as well.
Reaction wheels, those are the spinning wheels inside a spacecraft that let it turn and hold steady without using fuel. Lose those and you lose fine control of which way you're pointing.
That's the one. And losing 2 of 3 is serious, especially because there was already a wobble with one wheel earlier in commissioning that they patched in software. The good news, Link is not lost. It's still powered, still in contact, and its other major systems are behaving. The team's plan is to use Link's electric thrusters, its xenon propulsion, to stop the spin over the next few days, then re-establish stable pointing, update the spacecraft's guidance and navigation to work around the dead hardware, and only then sit down with NASA and decide whether it's still safe to attempt the approach and capture of Swift.
So the rescue isn't canceled. It's on hold while they figure out if the rescuer can still do the job.
That's exactly it. And I'll flag for everyone, this is a live situation as of when we're recording. By the time you hear this, the team may already have stopped the spin, or the picture may have changed again.
But step back and look at the shape of it. The same little observatory that just helped us find an invisible black hole halfway across the universe is now clinging on in low Earth orbit, waiting to see if its own lifeboat can limp over and give it a shove. Space is hard. Even the rescue missions need rescuing.
We'll keep you posted as that one develops. And that brings us to the sky over the next few nights. And there's one thing you cannot miss because it's going to be lighting up the whole night. The moon.
The full buck moon.
The full buck moon, full tonight, the 29th, and near enough to 100% lit for a couple of nights either side. Gorgeous to look at as it climbs the eastern sky after sunset. But it is a floodlight, and that shapes everything else we can and can't do this week.
Starting with the meteors, because there are 3 showers on the go at once.
There are, and this is where our two hemispheres genuinely differ. The headline shower right now is the southern Delta Aquariids, peaking over the next couple of nights. And the clue is in the name. For our southern hemisphere listeners, this one's yours. The radiant, over near the bright star Fomalhaut, rides high, almost overhead in the pre-dawn hours. So from Australia, New Zealand, and southern Africa, you're in the best seats on Earth for it.
And for the north?
From North America, it's lower and stingier, though observers in the southern United States still get a fair look. Best window everywhere is the couple of hours before dawn. But big caveat this year. That brilliant moon is going to wash out most of the faint Delta Aquariids, so temper expectations.
If the faint ones are drowned out, what's worth staying up for?
The fireballs. The Alpha Capricornids are active at the same time. They're sparse, only a handful an hour, but they specialize in slow, brilliant fireballs bright enough to punch through moonlight. And unlike the Delta Aquariids, the Capricornids play fair. They're just as good from either hemisphere. So the tip for everyone this week, don't chase quantity. Get comfortable, be patient, and wait for one big, slow fireball to make your night.
And the shower everyone's really waiting for.
The Perseids. And here's the good news to hold on to. They're building now, but they peak on the night of the 12th into the 13th of August. And this year, the timing is close to perfect. The peak lands right on the new moon. Dark skies, no moonlight, potentially the best Perseids in years. They favor the northern hemisphere, but mid-southern latitudes will catch some too. Mark it, the night of the 12th of August is the one to keep clear.
And that same date is a big one for another reason.
It is a total solar eclipse on the 12th of August, with the path of totality crossing Greenland, Iceland, and a slice of Spain, and a partial eclipse visible across much of Europe and parts of North America. We'll have full timings closer to the day. And the one rule that never changes wherever you are, never look at the partial phases of a solar eclipse without certified eclipse glasses, ISO 12312-2, or a properly filtered telescope. Ordinary sunglasses will not protect your eyes. That safety line stays in, no exceptions.
One quick planet note before we wrap the sky.
Yes, say goodbye to Jupiter for a little while. Today, the 29th, Jupiter reaches solar conjunction. It's passing almost directly behind the sun from our point of view, so it's lost in the glare and out of action for the next few weeks. It'll creep back as a pre-dawn object later in August. And for early risers, Mercury is putting on its best morning showing of the season, low in the pre-dawn east.
And we have to close the loop on our lead story.
We do. If you're up before dawn chasing those meteors, look for Orion climbing in the east and find Betelgeuse, that bright orange shoulder. From the southern hemisphere, it's high in the northern sky and flipped over. From the north, it's lower in the east before sunrise. Either way, give it a nod. You now know something about that star that nobody knew for 100 years. It's got a companion.
Before we go, a bit of proper news from our end. We've just launched the brand new home for the show, astronomydaily.io.
Same address, you already know, but it's had a complete makeover and there's a lot there now. You can stream the entire back catalog, every episode. There's a news feed that updates continuously through the day so you can keep up with the latest space and astronomy headlines between episodes. You can read listener reviews and leave one of your own. And you can sign up for our daily space news newsletter to get it all straight to your inbox.
And there's a spot to drop us a line. Questions, suggestions, a story you think we've missed, or just to say good day. We read them.
It's brand new, so we genuinely love your feedback on it. Head to astronomydaily.io, have a wander around, and tell us what you think, what you love, what you'd change. Help us make it yours.
That's Astronomy Daily for Wednesday, 29th of July. Betelgeuse's 100-year secret, a black hole in the wrong part of town, Roman on the clock, and a rescue mission holding its breath.
Thanks for spending part of your day with us. Look after each other, and whichever hemisphere you're in,
Clear skies.